In this demonstration, we will observe the differences between polymers due to the variations in intermolecular forces which cause the materials to have different properties. Specifically, I am comparing acrylonite butadiene styrene, known as ABS, and polymethyl methacrylate, known as acrylic, and the different thermal properties. Between the atoms, intermolecular forces hold them together with varying levels of strength. For polymers, there are van der Waals forces, dipole-dipole interactions, and hydrogen bonding. Van der Waals forces are the weakest of the three forces, which involve instantaneous dipoles between the constant movement of electrons due to Heisenberg's uncertainty principle, meaning that the energy of electrons can never be zero, or in other words, the electrons have to keep moving. Now, due to these constant movements of electrons, a difference in charge is created as the electrons move from one side of the atom to the other, and back and forth, almost instantaneously. This causes a relatively small intermolecular force that varies with the amounts of electrons, shape, and size. The molecular packing of acrylic is more linear, which aligns the chains closer together, increasing the total effect of the van der Waals forces, whereas ABS is more irregular, therefore less force. Dipole-dipole forces are a result of permanent polarities between a bond with significantly different electronegativities. This causes greater intermolecular forces than van der Waals forces due to the electrostatic attraction of the positive and negative ends of the molecule. This force is stronger the greater the difference in charge, as it leads to a greater attraction, in addition to proximity causing a greater force. For ABS, the nitriles, which are carbon triple bonded to nitrogen, where the nitrogen is more electronegative than the carbon, while also being triple bonded, bringing the two into closer proximity, causing the dipole to be relatively strong due to this dipole moment, whereas in acrylic, with esters, a carbon double bonded to oxygen, the dipole moment is less as it is double bonded, therefore the carbon and oxygen are not as close to as the nitrile bond. Hydrogen bonds are a specific form of dipole-dipole force, where a hydrogen is bonded to a very electronegative atom, often being nitrogen, oxygen, or fluorine. Hydrogen bonds also assemble themselves linearly, which increases the force. In ABS, the hydrogen bonds form on the nitrile, and for the acrylic, the hydrogen bonds form on the carbonyl. For both polymers, the hydrogen bonds increase the boiling and melting temperatures when compared to similar-sized molecules without the hydrogen bonding, requiring more energy to counteract the force of the hydrogen bonds. This is seen with the results of the demonstration. The ABS began to soften at 111.4 degrees Celsius, whereas the acrylic began to soften at 133 degrees Celsius. This reflects the main difference between ABS and acrylic, being the strength of the intermolecular forces. With ABS having overall less electronegative hydrogen bonds than acrylic, it results in ABS not being able to withstand as much thermal energy as acrylic. This aligns with known quantities, with ABS reaching its glass transition temperature at 100 degrees Celsius, whereas acrylic reaches it at 120. Ultimately, the intermolecular forces, van der Waals, dipole-dipole, and hydrogen bonds within the polymers influence the different thermal properties of ABS and acrylic.